In this video, we're going to look at how to analytically determine the value of the indefinite integral, otherwise known as the antiderivative. When we first started learning about derivatives, we first used the limit of the difference quotient to find the derivative. Then we learned rules to make it easier. Likewise, with integrals, we started with the Riemann sum being the actual definition, and now we're going to learn rules. In this calculus class, we are only going to begin doing that. Most of the rules we will learn in Calculus 2 and 3, primarily Calculus 2. To begin with, we'll start with the integral of 0 dx. Now, to solve this, we remember that the derivative of a constant, some constant c, doesn't matter what c is, as long as it's a constant, is 0. We therefore can say that the integral of 0 is some constant plus c. Now c could be a negative number, could be a positive number. All that it needs to be is a constant. And we can double check by taking the derivative of c and see that we get 0. These are equivalent statements. Moving on, the integral of 5. Well, if we will recall, the derivative of 5x equals 5. Therefore, we can say that the integral of 5 dx is 5x. This is quite true. However, whenever we do an indefinite integral, we need to remember to add plus c. Sometimes that c is important, sometimes it is not, but we always need to add it to an indefinite integral, where c is simply a generic constant. We can turn around and take the derivative of 5x plus c and see that we always get 5. Notice that the dx or the dy tell us what variable we are integrating with respect to. Hence, in this example, since here we've gotten 5x, because x is our variable of integration. Here, y is our variable of integration. So the answer to this would be 5y plus c. Moving on, we have 2x dx as our integral. We recall that the derivative of x squared equals 2x. Therefore, we can say that the integral is x squared. We also need to remember to add plus c. In general, the derivative of x to the power of n is n times x to the n minus 1. This is the power rule for derivatives. Likewise, we can say that the power rule for integrals, working backwards, is for x to the n dx is 1 over n plus 1 x to the power of n plus 1 plus c. If we apply that to something like 15 times x to the 3 over 2, we get 15. Integral of 3 over 2, dx, I'm going to set n equal to 3 over 2. So we get 15 times, 1 over n, that's going to be 3 over 2 plus 1, times x to the 3 over 2 plus 1, plus c to the whole affair. 3 over 2 plus 1, that's the same as 5 over 2. So 15 times 1 over 5 over 2, x to the 5 over 2 plus c. If we further simplify this, we get 15 times 2 over 5 x to the 5 over 2 plus c, or simply 6 x to the 5 over 2 plus c. Likewise, as our final example, we 3 times e to the 3x. If we recall, the derivative of, let's have a little bit more room, the derivative of e to the 3x is 3e to the 3x. Therefore, the integral of e to the 3x dx is e to the 3x plus c.